All right, welcome to another session of Krazifizix revision. And this we are focusing on just a topic for this session. And our focus is on acid and base. Remember, www.krazifizix.org.za. That's where you find us, and you can get other videos. Acid and base, this is part 2. We had a part 1 where we did 3 questions in length and explained a whole lot of other things. All right, so now we walk through part 2 quickly. Okay, here we go, part 2. The Ka values, if you go to our part 1 video, we talked about Ka, where we talk about strong acid, strong base, weak acid, weak base. The Ka values for 2 weak acids, organic and carbonic acid, are as follows. And we also gave examples, definitions in our first video. So here we're just going to link it up with that and move very swiftly. Define the term weak acid. A weak acid is an acid that what? Ionizes what? Partially. It ionizes partially in water. That's a weak acid, a weak acid. Okay, so we're just running through because we want to focus on more calculations. Which acid, oxalic acid or carbonic acid, is stronger? Give a reason for your answer. All right, if we look at the Ka values, which is what determines, you would see that oxalic acid Ka value, which is 5,6 times 10 to the power negative 2, is actually greater than 4,3 times 10 to the power negative 7. So this is a stronger, weaker acid. All right. So which one is stronger? Which one is stronger? Oxalic acid. Give a reason. The Ka value of oxalic acid is greater than the Ka value of carbonic. All right, and we're done. Oxalic acid ionizes in water according to the following balanced equation. Write down the formulae of 2 bases. This is a repeated question. All right, we did something like this again in that other video. All right, 2H2O, and what do we have? COO. All right, 2 minus 2, 2H30. All right, again, this is a diprotic acid because we have 2 hydronium ions produced, but that's not our focus. All right, if you notice here that it was 2H2O here, and here it becomes 2H30 plus, which means this has accepted. So if it accepts, automatically it's a base, while this one is an acid. When an acid loses a proton, it becomes a conjugate what? Base. When a base accepts a proton, it becomes a conjugate what? Acid. So what are my answers? I'm going to use a red one to just show my answers. Write down the formulae of 2 bases. Water, we have those 2 bases. So just write down those 2 formulas and then you are done. So watch out for what accepts and what donates. All right, 7.4. Let us prepare 2 dm cube of sodium hydroxide solution of concentration. All right, so we have the concentration of the base, which is what? 0,1 moles per dm cube. Now, what do we want in this question? We want a pH. What's the formula for pH? All right, pH. Okay, by the way, we need to write this down. This is a base. All right, pH equals to negative log. All right, please. Now, since we are dealing with a base, I cannot put this concentration here. No. Since this is a base, this concentration that we have here is that of a base. So, method number 1 is to use the auto-ionization of water. You get this formula on your formula page. It's right there on your formula page. Now, what do we know? What do we know? We do have our concentration. I'm looking for this. This is what I'll take into the base, into the calculation. All right, but what's my base? It's a 0,1 equals to 1 times 10 to the power negative what? 14. And what will this give us? The concentration here will be 1 times 10 to the power negative 14 divided by 0, 1. All right, 0, 1. All right, so if you do that mathematically, you should know now that what we are going to have is 1 times 10 to the power negative what? 13. Then we can look for the pH of that negative log of this. Now I have that formula there, and what am I going to have? pH will be equal to negative log 1 times 10 to the power negative 13, and that will give me 13. All right, and that you're done. Or alternatively, if we say pH, okay, since we have the base, POH equals to negative log OH minus, and POH is now negative log of 0, 1. This would actually give you 1. You can check on your calculator now. But pH plus POH equals to 14. I'm looking for pH plus 1 equals to 14. pH automatically becomes what? 13. Either of the two ways. What you need to notice is when you're given a base, you need to find the concentration equivalent of the hydronium ion. All right. During the titration of sodium hydroxide solution, okay, during a titration of sodium hydroxide solution, in question 7.4, we dilute oxalic acid. Let us find out that 25,1 cm cube of sodium hydroxide neutralizes. If you go back to our video, when we say neutralize, you know the formula that comes to mind. All right, what do we have? We have the volume of the base. Hold on. Okay, during the titration of sodium hydroxide solution in question 7.4, the concentration of the base is 0, 1 moles per dm what? Cube. What else do we know? Okay. Then let us find out that 21,5 cm cube of the base. All right. So what do I have? The volume of the base is 0,0251 dm cube. Remember, we divide by 1,000. Neutralizes exactly. Volume of the acid is given 0,0142 dm cube. 1, 2, 3. All right. Now the balanced equation is given. Calculate the concentration of the oxalic acid solution. Okay. Now automatically, since this talk about complete neutralization, we discussed this in the video prior to this, CAVA over CBVB. Now what's the number of moles of the acid? You go back to your equation and check. It's balanced, 1 there. Number of moles of base is 2. Concentration of the acid is unknown. Volume of the acid is 0,0142. What is the concentration of the base? Is 0, 1. And what is the volume of the base that was used? 0,0251. So what do? We cross multiply and divide. All right. So CA should actually be equal to 0, 1 times 0,0251 divided by 2 multiplied by 0,0142. All right. Now let's quickly get things done with our calculator. It's going to be 0, 1. All right. 0, 1 times 0,0251. All right. 0,251 divided by 2 multiplied by 0,0142. All right, 0, 1. Okay, my 1, 1, 4, 2. And what do we have here? 0,088, which is basically 0,09. All right, so the concentration of the base, of the acid rather, is 0,09 because it's 0,088. All right, and if we leave it, so it's 0,1 moles per dm cube. All right, 0.1 mole per dm cube. Okay, the next question says, the following indicators are used. Which one of the indicator is most suitable? What are we dealing with? We're dealing with a strong base, if you go back to that video, and a weak acid. The base is the strong one, so we are going to form a basic salt. A basic salt. So we go back to our pH and check the one that is basic. It's that. It's indicator B. Indicator B. And if the examiner wants you to specify, you now actually know, remember my best, no, indicator, this is a basic, indicator C. Remember C is basic, all right? C is basic. I was using the B for B, no, it's basic, so it's C, all right? My best, my beautiful princess, all right? And this one is phenolphthalein. All right, we did a good explanation in the first video on choice of indicators. Please check the first video again and go through. This is acidic, this is neutral, this is basic. I'm forming a basic salt, so I use a basic indicator. All right, question done, 17 marks. Okay, here is another one. Magnesium hydroxide is often used to relieve an upset stomach. All right, the pH of HCl in a person's stomach is 1. Calculate the concentration of hydrochloric acid in the person's stomach. All right, what do we know? We know the pH. pH equals to negative log hydronium what? Air. Our pH is 1, so we have negative log hydronium ion concentration. What do? It becomes negative 1 equals to log of that. Now, how do we do that on our calculator? It becomes a shift log, which is 10 raised to power negative 1. All right. And you can just confirm that on your calculator in case you don't know how to deal with the shift log. Just a shift, and then you have your log, and then negative 1. And your answer is 0.1. So the concentration of hydronium ion is 0.1. Okay, now you should be used to pH. All right, will the pH in the stomach increase, decrease, or stay the same after taking the dose of magnesium hydroxide? Remember, our pH in the stomach is 1. All right, if you now add a base to it, you are trying to neutralize. So your pH should be increasing to 2, 3, 4, 5, until it gets to somewhere 6 and 7. So the correct answer is what? Increase, because as it increases, it tends towards the neutral. All right, a person takes a dose of magnesium hydroxide. Write down the balanced equation for the reaction that takes place in the stomach. All right, so now this is MgOH2 plus HCl. Automatically we should have water. So if I'm going to have water, let me break this down. What will happen here is this. This would first break down into Mg2 plus, all right, Mg2 plus, OH minus, H plus, and Cl minus. Now I want water. Here is my water. So what do I have? I am going to have H2O plus. Now this and this would combine, and we have MgCl2. The 2 here comes down here. But is it balanced? No. Chloride atom here, you have 2. Can I put a 2 here? Now my hydrogen is 2. Okay, so we don't need this one anymore. I will clean it so that it doesn't confuse you. That's just showing how we do our ion exchange. All right. Is it balanced now? Let's see. Hydrogen here is 2 plus 2, 4. And it's 2 here, so I need a 2 here. My oxygen is now 2, magnesium. Yes. Now we are balanced. Okay. Explain what is meant by neutralization reaction. All right. Neutralization reaction. It is a reaction between an acid and a base to form salt and water. All right, an acid, a reaction between an acid and a base to form salt and water. Now 7.3. 7.3. All right, 7.3. All right, 7.3. 12 cm cube of sodium hydroxide of concentration 0,1 and 48 cm cube of barium hydroxide of unknown concentration are mixed in a large flask, and the solution is homogenized. All right, why homogenized? We are dealing with base of hydroxide solution but of different metals. So homogenized means the word homo just simply means same. So we're talking about same ions but different metals. This solution is completely neutralized by 54 cm cube of 0,05 moles per dm cube sulfuric acid solution. Calculate the concentration of barium hydroxide. Okay, we have two bases here. Number one, volume of base 1 is 12 cm cube. Okay, and the concentration of base 1, which is sodium hydroxide is 0,1 moles per dm cube. Okay, and the volume of base 2 is 48 cubic centimeter there, and the concentration of base 2 is unknown, and this is barium hydroxide. Okay, now let's go check the volume of the acid. Information we have, volume of the acid is 54 cm cube, and the concentration of the acid is 0,05 moles per dm cube. All right, we're looking for concentration of the base. All right, we need to quickly write our equations. There are going to be two reactions simultaneously going on here. First is, since we know the sodium hydroxide, let's write the reaction of sodium hydroxide plus sulfuric acid. Okay, we should be used to this now. Na2SO4 plus H2O. Balancing, I need 2 NaOH and then 2 H2O. Balanced. All right, now I've already written all our data. There's complete neutralization here, complete neutralization, because the question mentions that this solution is completely neutralized. So what we need to do is to find the number of moles of this acid that was used to neutralize sodium hydroxide first. Okay, Na over Nb equals to CaVa over CbVb. Number of moles of the acid from my balanced equation is 1. Number of moles of base is 2. Okay, do we have the concentration of the acid? All right, go back to your data. We have everything. 0,05. Volume of the acid is unknown. Do we have the concentration of the base? 0,1. And what is the volume of the base that was used? Sodium hydroxide is 12, which is 0,012. All right, 0,012. Now somebody is saying, but we have the volume of the acid as 54. This is the entire volume of the acid, 54. Out of this 54, some were used to neutralize sodium hydroxide, and the remaining used to neutralize barium hydroxide. Hence, we are calculating. All right, if you have your calculators, okay, let's write this expression before we calculate. Va will be equal to 0,1 times 0,012 divided by 2 times 0,05. All you needed to do was just to cross multiply. And then what do we have? With your calculator now, 0,1 multiplied by 0,012 divided by 2 multiplied by 0,05. All right, what do we have here? 0,012. All right, so we have the volume of the acid as 0,012. 0,012 dm cube. was used, of H2SO4, was used to neutralize sodium hydroxide. Now the question is, what is the volume of the acid that will be used for barium hydroxide? Volume of acid used for barium hydroxide. Now it will simply be 0,054 minus 0,012, because that is what we are going to have left. Now that's our excess. 0,054 minus 0, what do we have? 0,042. All right, so the volume of acid used now here is 0,042 dm what? Cube. Okay, now barium hydroxide plus we wrote this equation also a while ago. What are we going to have? We are going to have what? Barium sulfate. Okay, let me break this down again just for clarity. First, it's Ba2 plus, this 2 here, OH minus. All right, I'm going to have H plus and SO42 minus. That is my water molecule there. So I'm going to have H2O. Now, because this H22, this is grade 9, writing chemical equations, barium sulfate, and is this balanced? We have 4 hydrogens there, so I need a 2 here, 2 oxygen. Okay, now we have a balanced equation. But what we need is actually the acid and the base. So again, because it is complete neutralization, I repeat that same neutralization formula. Number of moles of the acid now is 1. Number of moles of base is 1. Concentration of the acid, it's still the same acid, 0,05. What is the volume of the acid that we now used here? 0,042. That's what we calculated. Over concentration of the base is what we are looking for. And what is the volume of the base we were given? 48. 0,048. Now, what would your answer be? Okay, running out of page. What would your answer be? If you cross multiply, we're going to have 0,048 CB will be equal to 0,05 times 0,042. We can then divide both sides by 0,048. What will the concentration of the base be if we do our calculations quickly? It's going to be 0,05 multiplied by 0,042 divided by 0,048. All right, 048, and your answer is 0,044, which is 0,04. All right, 0,04 moles per gm cube, and then you have yourself 8 marks in that question. Very good question, different approach, and that's how we work things out. All right, let's find 2 more questions. In this session, we just do 4 questions on acid and base. Let's find 2 more questions to quickly deal with. All right, another question here. Define an acid in terms of Lowry Prostate theory. Okay, these are 3 marks. A proton donor, and you're done. An acid is a proton donor. All right, carbonated water in an aqueous solution of carbonic acid, H2CO3 ionizes in 2 steps. Once you see 2 steps, we're talking about diprotic. All right, but write down the formula of the conjugate base of H2CO3. What we simply need to do is to lose 1 proton. Remember, an acid loses a proton and becomes a conjugate base. So if I lose a proton, I'm left with 1, CO3. Now, because I am losing, remember the net charge here is 0. I am now losing 1. I have a -1, and you are done. Simple and straightforward. Write down a balanced equation for the first step in the ionization of carbonic acid. All right, first step. But in this question here, there are 2 steps. Remember, this one can also lose and become what? CO3 2 minus. This is also a base. Now this here is my ampholyte. It's an ampholyte because it can receive. When it receives, it becomes that. When it donates, it becomes that. Ampholyte. All right, write down the balanced equation for the first step of the ionization. Now when we talk about ionization, we must now talk about water. H2CO3 plus H2O. Ionization. We lose a proton. So we have HCO3 minus plus H30 plus. Remember, this one is 0. We add 1 plus 1. And then it's done. The pH of carbonic acid at 25 degrees Celsius is 3,4. Calculate the hydroxide ion concentration. All right. pH equals to negative log of this. But now we are told that the pH of carbonic acid is 3,4. So it's 3,4 here, negative log my hydronium ions. All right, I'm sure you know how to do this now from our previous questions. So we just run through without wasting time. What are we going to have? We are going to have a shift log of negative 3,4. And what's my answer? My answer is 3,9 times 10 to the power negative 4. Okay, 3,9 times 10 to the power negative 4. But the question says calculate the hydroxide ion concentration. Hydroxide ion concentration. Hydroxide ion concentration. All right. All right. But we're looking for the hydroxide ion concentration. So OH minus H30 plus should be equal to 1 times 10 to the power negative what? 14. So OH minus 3,9 times 10 to the power negative 14 should be equal to 1 times 10 to the power negative 14. If we can just divide both sides, what are we going to have? All right, we are going to have 1 times 10 to the power negative 14 divided by my answer. And I have 2,511, which is 2,51 times 10 to the power negative 11. 2,51 times 10 to the power negative 11. It's concentration, so we do with moles per dm cube. Okay, X is a monoprotic acid. We've answered this question before. Go to our first video. We did a lot of that. Monoprotic acid is an acid that donates just 1 proton. All right. A sample of X is titrated with a standard solution using a suitable indicator. At the end point, it is found that 25 cm cube of X, okay, volume of my acid is 0,025, okay, dm cube, 5 dm cube of X is neutralized. You know what I'm looking at already. Na over Nb equals to CAVA over CbVb by 27,5 of the sodium hydroxide solution. All right, so volume of the base is 0,0275 gm cube, and the concentration of the base is 0,1. 0,1. Calculate the concentration of the acid. Again, I'm sure right now you know what to do. First, we need to write a balanced reaction. All right, balanced reaction between an acid X, but it is monoprotic. If it is monoprotic, and between, so acid X plus sodium hydroxide, because it is monoprotic, it's going to be 1 to 1. So the number of moles and the number of moles there will be equal. CAVA over CbVb. Number of moles 1 over 1. What is the concentration of the acid? We're looking for the concentration of the acid. What is the volume of the acid used? 0,025 over concentration of the base 0,1. And what's the volume of the base? 0,0275. All right, what do we do now? We just simply cross multiply and divide. 0,1, let's write it nicely, 0,1 times 0.075 divided by 0.025. And what will our answer be? And you are about to just get your 5 marks there quickly. All right, it's going to be 0.1 multiplied by 0.0275 divided by 0.025. 025, and our answer is 0.11 moles per gm cube. All right, concentration of the acid is 0.11 moles per gm cube, and it's 5 marks there. 5 easy marks for you. Get the formula right, get your substitution right. Okay, if I were to mark this, let me just show us quickly. It's 1 mark for the formula, 1 mark for the formula, ratio, numerator, denominator, final answer with a unit, 1 mark. All right, 7.3.3, the last one. The concentration of hydronium ions in the sample of X is 2,4 times 10 to the power negative 4. Is acid X a strong acid or a weak acid? Explain your answer by referring to the question. All right, let's check something here. The concentration of hydronium ions, all right, is equal to 2,4 times 10 to the power negative 4, all right, which is basically 0.0024. There are 3 zeros there, all right, moles per gm cube. Now that's the concentration of an hydronium ion in the sample of acid X. By the way, what is the concentration of the acid itself? The concentration of the acid itself is 0.011. Now, is it going to be a weak acid or a strong acid? Now we say if it is a strong acid, H3O plus must be greater than the concentration of the acid, then it is strong. But if this is lesser than the concentration of the acid, it means it is weak. It only ionizes partially. So if we compare this, the hydronium ion concentration is far less than the concentration of the acid. So it is automatically a weak acid. So I'll answer by saying hydronium ion concentration is lower than the concentration of the acid X. Concentration of acid X. Therefore, it is a weak acid because it ionizes what? Incompletely. Incomplete ionization. All right. Incomplete ionization. Another 20 marks given there, and you get your marks on acid and base. Okay, we'll look for one more question just to make you understand more, and then you should be able to deal with any other question. All right, let's look at one more question in this session, and then this session is very short because we're just attacking the questions the way they are. Hydrogen carbonate ions react with water according to the following balanced reaction. Define an acid in terms of Lowry prostate. Again, we have this definition repeated. An acid is a proton donor. Now, do you see the importance of doing questions? You actually find that the answers are the same. Write down the formula of 2 acids. Now, 2 acids. An acid is a proton donor. Let's go check which one is my acid. So I've got these 2, and I've got H2CO3 plus OH minus. Okay, compare. Let's compare this and this. What happens? I lose a proton. Automatically, this is an acid. An acid losing a proton becomes a conjugate what? Base. On one side, you cannot have both bases. If one is a conjugate base, the other one is a conjugate acid. This is an acid. Automatically, this is a base. Write down the 2 formula of my acid. I'm going to circle them with the blue. That's my acid, and that's my acid. You move straight to the next question. Write down the formula of a substance that in this reaction that can act as an ampholyte. Water is the most suitable example. An ampholyte, again, is something that can react as an acid or a base. 7.2. During an experiment, 0.5 dm cube, all right, volume of which one? It's an acid now, all right, 0.5. Concentration is 0.1. Is added to 0.8, okay, which is the volume now, 0.8 of the base, and the concentration of the base is 0.25. I hope you get my data from the question. All right, the balanced reaction is that. Is it balanced? Let's check. All right, sodium, yes, it's balanced. Now, you see in this question, there is nothing called complete neutralization. So this is an incomplete. And I'll prove that to us right now. Calculate the concentration of the hydroxide ions in the solution on completion of the reaction. Calculate the hydroxide concentration. Guys, we cannot just jump here and use NaCa because we don't know if it is a complete what? Neutralization. All right. Oh, by the way, hold on. Let me just go. Okay, fine. It's okay. One other thing, we mentioned this earlier on in the other question. This also can act as an ampholyte if you go back to our previous question. All right. Now, let's check quickly. Since we're talking about incomplete, we need to find the number of moles of the acid. 0.5 times 0.1, and that will be 0.05 moles of the acid. Number of moles of the base is 0.25 times 0.8, and what would that be? That would be 0.2 what? Moles. All right, let's go check something quickly. Let's check something quickly. In my reaction, 1 mole of the acid, all right, let's do this. 1 mole of HCl would react with what? 1 mole of sodium hydrogen carbonate. But let's check something. If you actually see here, this is very small. 0.05 moles of HCl will only neutralize 0.05 moles of sodium hydrogen carbonate, which means I have excess of number of moles of the base, sodium hydrogen carbonate. So HCl is my limiting reagent. Okay, so the number of excess sodium hydrogen carbonate, remember what I have 0.2 and I only neutralize 0.05. So the number of excess mole is 0.15 moles of sodium hydrogen. That is why the question said calculate the concentration of the base. All right, that means it is excess. Now, what is concentration? All right, now if you look at this, this is just one base. So the number of moles of my hydroxide ion will be also equal to 0.15. Why? Because when this ionizes, it only produces 1. Okay, now what is concentration? Number of moles divided by volume. What is the number of moles that I have? 0.15. Here I am talking about sodium hydrogen carbonate. But what is the volume of the solution? Now remember, this is in the solution. By the way, I have 0.08 of the base and 0.05. If we add that together, you are going to get 1.3. And that's my concentration now. What is my concentration? My concentration now is 0.5 divided by, 0.15 divided by 1.3. And that will give us what? 0.115, which is 0.12. That's the concentration. 0.12 moles per dm cube. So your acid and basic question, do you see the similarities? It's either it's completely neutralized or not. If it's neutralized, you know the formula to use. And if it's not neutralized, you know you have to find your limiting reagent. All right. pH of the solution, negative log hydronium what? Ion. But again, I do not have hydronium ion right now. I have hydroxide ion. So what do? Again, I go back to my auto-ionization of water, which is 1 times 10 to the power negative 14. and I need this now. I need this now, and this is 0,121 times 10 to the power negative 14. If we divide both sides, what are we going to have? We are going to have 0, okay, it's going to be 1 times 10 to the power negative 14 divided by what? My previous answer, or since we have rounded up 0,12, what do I get? 8,33 times 10 to the power negative 14. 8,33 times 10 to the power negative 14. 8,33 times 10 to the power negative 14. All right? So pH now will be equal to negative log of hydronium ion. And that becomes negative log 8,33 times 10 to the power negative what? 14. And that would simply be, let's go check quickly, negative log of my answer. And what would that be? 13,079, which is 13,08. All right, ladies and gentlemen, this is how you work through your acid and base questions. I hope this session has been, it's quite short, straightforward, to the point. I hope it has been quite beneficial. Remember, you can get more on our webpage. Just a reminder, you can get more on our webpage, and there it is there, www.krazifizix.org.za. Share with friends, let everyone know who we are. Send us a message on our page. There's a page where you can put a message there. Send us a message. And finally, just to remind you of our materials. All right, very beneficial. We have our science materials. We have that of grade 12, we have grade 10, and we have grade 11. That's a physical science grade 10, grade 12 book. All right, we have our grade 10 and 11 as well, and we also have our maths spectrum. All right, we have our maths spectrum, which is both for paper 1 and paper 2. These are very, very beautiful materials that you can use for your self-study. All right, thank you again, and this is Bishop signing out. See you in the next video. 0817442103. Drop us a message again on krazifizix.org.za, and we would be glad to respond. Have a good day and good luck.